Building on yesterday. Let's look at an example. Suppose a linear pattern contains the term value 59. 59 is not close to the beginning of the pattern. In other words, we can't say that our pattern starts at 59 and goes along, and we can't say that it's 57 and then 59. So we want it to be a little further along in the pattern. So what could our pattern rule be? It could be something as simple as 31, 33, 35, and so on. And because we see that we're dealing with all of the odd numbers, then we know eventually we're going to end up at 59. Supposing this time we started at 759, next would be 659, 559, 459, and eventually we end up down at 59. And the term position, there's our n and there's our value, 1, 2, 3, 4, 5, 6, 7. So 59 in that case would be the 8th term. Now we're asked to create pattern rules by selecting whole number values to fill in the blanks. This is pretty arbitrary. We could say 7n plus 10, 3n minus 15, 8 minus 4n, and negative 6n minus 9. Now we're supposed to use each pattern rule from question 1 to test whether each number above here is in the pattern. If it's in the pattern, use an equation to figure out its term position and show your thinking. So the first thing we need is all of the pattern rules from question 1. So for this we're going to be using some of our algebra, because what we're saying, supposing we start with number 234, we're saying that 7n plus 10 would be equal to 234 for some value of n, which we don't know yet. So that equation has to be true, and n has to be a whole number. It can't be a decimal or a fraction. So solving this using algebra is 7n. We're going to subtract 10 from both sides. So we subtract 10 from this side to get rid of the plus 10. So we end up with 7n is equal to 234 minus 10, which is equal to 224. So 7n is equal to 224. Now we need to divide that both sides by 7 to get this 7n, to get the n alone. So we got n is equal to 224 divided by 7, which is equal to 32. Now for fun, we'll choose a different number here, 500. Let's see if 500 works in the 3n minus 15. Using the same approach, 3n minus 15 is equal to 500. Then we're going to add 15 to get rid of this. We're going to add 15 to both sides. So we end up with 3n is equal to 500 plus 15. So 3n is equal to 515. So n is equal to 515 divided by 3. Using my divisibility rule for testing for divisibility by 3, I need to add up the digits in this number and then see if that total is divisible by 3. So 5 plus 5 is 10 plus 1 is 11. Well, 11 is not divisible by 3. So we know then that 500 is not one of the terms in this expression. So it's not one of the terms in that sequence. Now let's try 8 minus 4n is equal to negative 440. So I want to get the n all by itself. So in this case, I'm going to move the n this way and the 440 back the other way. So that means I end up with 8. I've got to add 440 to both sides to move it from here over. And then the 4n is going to get added to both sides. So I get 4n on that side. So now I've got 448 is equal to 4n, and that means n is equal to 448 divided by 4. Divisible by 4 100 times, and 48 is divisible by 4 12 times. So that means that n is equal to 112. So I know now that negative 440 is one of the terms of this expression 8 minus 4n. And last but not least, negative 6 minus 9n. Let's see whether negative 150 is one of the terms. So we've got negative 6 minus 9n is equal to negative 150. Since I've got negatives of all the terms, I can multiply everything by negative 1 so that I end up with positive terms everywhere. 6 plus 9n is equal to 150. That makes it a little easier to deal with. Now I'm going to subtract 6 from both sides. So I've got 9n is equal to 150 minus 6. So that's getting rid of the 6 on that side. And so I've got 9n is equal to 150 minus 6, which is 144. And then n is equal to 144 divided by 9. And if I do 144 divided by 9, I get 16. 9 times 8 is 72. Doubling that, 72, gives me 144. So again, in this case, now we know that negative 150 is a term in this expression, or in that series. Your turn.